Okay, so at this point we are looking at question 3 from the control test 3 of September 2021. It's actually control test 2, not so. So you write the control test in term 1 and term 3, and cycle test in the other 4 terms, okay? So control test in 1 and 2. 1 and 3, sorry. So control test term 3. Okay, makes sense. Alright, so yesterday we got up until question 3. So I must answer now 3.1. Eh? We completed question 1 and 2. So in question 3, we are told that given f of x equals x over 2 and g of x equals sine x minus 30. Then we are told that on a set of axes provided on your answer sheet, sketch the graph of f and g showing the intercept of the axis, the turning points, starting and ending points for the interval negative 90 to 180. So on your answer sheet, you had something looking like this. Not so? So with that information, we can now draw this graph. The graphs. The first one, if I look at cos x over 2, the basic cos graph does that in 360 degrees. That is 1 and minus 1. That is cos of theta or cos of x, whatever. By putting a half in front of the x here, that means to say you're dividing your period by a half. Not so. So your period now goes from 360 now to 720. And it's the only change on this graph. So that is normally 180. It now goes to 360. That's normally 90, but now goes to 180. That's normally 270, which is 270 divided by half, which is I think 540 if I'm not mistaken. Okay? But if you're looking from 0 to 360, then it's only this part of the graph that gets drawn anyway. Not so from 0 to 360. So, if I take that into account, you're going to start at 1. We're going to go down to it's normally 90, but now it goes down to 180. Not so. So you go from 0 to 180. So I've actually highlighted it wrong here. Not so. I had to highlight from 0 to 180. That's a part of the graph I've drawn now. Not so. Now of course if I look at the other side of the graph does that as well. So this point there would have been negative 180. It's normally negative 90. Now it's going to be negative 180. But it's off this graph here. Can you see that? So in other words, I need to calculate the end point on the graph. The end point on the graph. So just pull the calculator up here. So how do I get the end point on the graph? I substitute 90 degrees where I see x. So it's going to be cos 90 in the negative over 2. So it's going to be root 2 over 2, which is 0.707. So at negative 90, it's 0.707, so that's going to be root 2 over 2. Okay? So remember, this is the maximum value. So the graph goes up there. Just draw it. It's normally one smooth curve there. We just do it properly. So it goes from there to 1 and down to 90, to 180. You all agree with that? Remember, this point here is negative 90 and root 2 over 2. That is your end point. Okay? You all agree with that? That's correct. Is it right or wrong, people? Is it wrong? Who got this answer right in the exam? Okay, now if I ask if it's correct, then you must say yes. Sorry? You have decimals. So you got 0,707. And I said that earlier on. So you can either have it like that or in decimal, doesn't matter. Okay. Since there's more than one graph on the system of axes, I label it. So that is F. Okay. Then the G of X graph. The G of X graph is a sine graph. So let's draw the sine graph. The basic sine graph does that, and that is normally 360. That is 1 and minus 1, and of course it goes this way as well. Looking more or less as the positive part. And, something like that. But what happens to this graph? It's shifting 30 degrees to the... It's moving 30 degrees where? To the right. Not so. So this is normally 0. It's going to move 30 degrees to the right. So 30 degrees. And then this is normally 180. And that is where I'm stopping. But if I move this 30 degrees to the right, this is now 210 degrees. This is normally 90. But 30 degrees to the right would give you 120 degrees. Not so. So I go 30. Normally 90 is at 120. So I get 120 and 1. And this is normally 180 as I indicated, but it's 210, so it's off the graph. So in other words, this would approach some value here. Remember again, that's an end point on the given domain. So that will be 180 and some y value. How do I calculate the y value? By substituting 180 into the diagram. Okay? Let's pull the computer back there. So you sorted with your homework now, no? Okay. Okay, so we now say 180 minus 30, sine of 180 minus 30. That gives us a half. Okay. Then of course this part of the graph here, that is normally negative 90, but it moves 30 degrees in that direction, it then gives you negative 60. Again, forgot you guys are this group, no? Don't talk. So we go there, that's part of the graph. And of course the graph will do that there. I would suspect that to be negative 90 and negative half. I could be wrong. I'll just check there. So it's negative 90. Yes, I am wrong. It's going to be negative root 3 over 2. Okay, this is a wild guess I took. Shouldn't be doing that. So it's negative root 3 over 2. Or your decimal equivalent on that. You should also get a mark for it anyway. Okay, and this is the graph of UX. People, what do you notice? We also have a y-intercept there that is not marked in the graph. Can you see that? So if we now consider that y-intercept there, it is where x is 0 and sine of negative 30 is negative half. Or you can put in the calculator and you should get negative half out. Okay. The reason why I didn't put that on or label that is because it's on one of the points that we have already drawn on the axis. Okay, that's the reason why I didn't show that point. Okay. Is there any questions? Any confusion? No. So let's look at the questions pertaining these graphs here. The first one in 3.2 says write down the amplitude of F. Okay, so let's just get the questions up here. So the first question was, what is the amplitude of f? So the amplitude is basically the measure from your neutral value, the central value, to the maximum. So if you're looking at the f of x graph, this should be your neutral value here, so the graph is not shifted to the maximum. And how many units does that cover? 1. So the amplitude on your f graph is 1. Okay, you all agree with that? Next question. The next question says, the period of f. Now what is the period? The time taken to complete one full cycle. Irrespective of which you're cutting off of the graph, or you're restricting the domain of the graph. Okay, or your x values on the graph. Irrespective of that, even if I had to draw a graph from 0 to 60, the domain on f will remain not the domain, but the period of f will remain the period of f. You guys understand? And the period of a normal sine graph, cos graph, is what? 360 degrees. That's why when we do general solution, it's k times 360. Not so? So the normal period on the cos graph is 360. So your period is going to be 360 degrees divided by your b value. And what is your b value in this case? A half. So 360 divided by half is 720 degrees. So it takes 720 degrees to complete one full cycle of the f graph. Okay. Any confusion there? Alright. Then in 3.2.2, the question says the range of G. So which graph is G of x? The green graph. Not so. What is the range? Range in all possible y values. Does this graph exist at negative infinity on your y? No. It starts existing at negative 1 till 1. Can you see from negative 1 to 1 this graph exists? You will agree with that? So how do I write the range? Y is greater than or equal to negative 1, but less than and equal to 1. Okay, that is inequalities. Or you could have written it in set builder notation. Not set builder, interval notation. So y is an element of, it has to be a block bracket, because that's inclusive, negative 1 and 1 block. Okay. Then in 3.3 it says use your graph to determine for which values or value of x is f of x times g of x less than 0. Where is f of x? This is now 3.3. F of x times g of x less than or equal to 0. What does less than or equal to 0 mean? Less than or equal to 0. What does that mean? It's negative. So under what condition, when I multiply two numbers, will it be negative? If it's a positive times a negative, or a negative times a positive. Under one of those conditions, would your solution be negative? You guys understand? So what does that mean to us? That means to us that f of x must be positive, while g of x is negative, or vice versa. F has to be negative, while g is positive. You guys understand that? Okay, so one must, in other words, one must be above this x-axis. This is y is equal to 0. If it's above the x-axis, it's positive. If it's below the x-axis, of course, it is negative. Are you all okay with it? So, from 90, is one positive and one negative? Yes. From 90 till which point is that the case? One positive and one negative. Till 30. Can you see that, people? From negative 90 to 30 degrees, one is negative, one is positive. Can you see that's continuous? Then what do you notice from 30 onwards? What do you notice? Both is positive. Both is above the line. And that's what we're looking for. Not so? And then there are 0 again at 180. Can you see that? At 180 there is 0. So my solution is then from negative 90 to 30 degrees. Can you see that? So we say x is greater than 90 but less than 30 degrees. Okay. However, there's an equal sign here on the inequality. So would there be an equal sign at 90? Negative 90? Yes. Why? Because at negative 90, one is positive and one is negative. You see that, people? So we'll have an equal sign. Would we have an equal sign at 30? Yes. Why? Because at 30, this product will be 0. Because here, g is 0 and 0 times any number will always be 0. That's why I have an equal sign here as well. Now we go to 180. Is there a 0 point at 180? Yes. So it can be at 180 as well. Okay, I think the calculator is in the way there. You just get the calculator out of the way. Sorry about that. There we go. Alright. So when do we leave an equal sign out if it is given as equal? When do we leave the equal sign out? We leave the equal sign out if the denominator is equal to 0. So say for argument's sake, you were given, let's go with a different color here. Let's use black. If you got f of x divided by g of x, for that is less than or equal to 0. The denominator can never be 0. So where's g0? At 30. So I would have omitted that equal sign at 30. You guys understand? Same solution. X has to be greater or equal to negative 90 but less than 30. And x can be equal to 180. Why? Because I hear the f is 0. What if I had gone the other way around? What if I had said g of x over f of x is less than or equal to 0? It's still where one is positive and one is negative, or one is negative and one is positive. It is still the case. But in this particular sum, what do we know? The denominator can't be 0. Not so? And where's f 0? If it's only 0 at 180, then I would have omitted that solution. Can you see that? So if it's not 0 there, nor is it 0 here. Can you see the variation on that? Also, when there's an asymptote, you never put an equal sign on because the graphs will never be equal at the asymptote. Okay, because the graph, one graph comes close to it, but never touch it. And which graph am I referring to there for the trig ratio graph? The tan graph. Okay, there's an asymptote on the tan graph. People, any confusion here? People, you must do a lot of these questions, okay? The graph questions, the three graphs. Because year after year we see learners, grade 12 learners leave this question out. Okay? The question is worth 10 marks, people. 10 marks. And yes, it's a lot to most of us. No? It's a lot of marks. So spend some time on it. It's going to be worth your while at the end of the day. Okay? Let's look at the other three graph that was given. Let's just pause here quickly. Okay, so in question 4, we are told that sketched below are the graphs of g of x equals a sine x plus q. So with the a in front of that graph, or in front of the trig function there, we know that there might be a change in the amplitude of the graph. Okay? Normally the sine graph is 1, but if you put your A value there, you might have changed. Okay. The P value is a shift either the up or down, which is your vertical shift. So let's investigate the G graph first. So there's our G graph. So this point here is -2 to 0. So what is that distance? From 0 to 2. What is that -2? What is this distance? 2 units, not so. And 2 divided by 2 is 1. So your A value is 1. Can you see that, people? No? And see here, they ask you to determine the values of A, P, B, and Q. So I'm solving A already. Okay? So it's 4.1. So A is going to be your maximum minus your minimum over 2. That's how we work out your A value normally. And since it's a sine graph, the sine graph normally goes up then down. Is that the case here? Yes. So this has to be positive. So it's going to be 0 minus -2, which becomes +2 over 2 is 1. So your A value is 1. Okay? But if you could see it straight away, you don't have to write it down. Okay? Just write 1. So you'll only get the mark for A is 1. Okay? Any confusion there, people? Now, if A is equal to 1, yes. But does G of X look like this graph here? No. There's a shift in this graph. The graph have shifted how many units? How many units down did the graph shift? Somebody must know. How many units did the graph shift down, people? Remember, this is 0, it went to -1. This is 1, it went to 0. And you said move down 2 units. Move down by how many units? 1, yes. And what value is that? That would be your P value. And P is equal to -1. Okay, let's look at B. What type of graph is B of X? Or F of X, sorry. What type of graph is F of X? It's a Cos graph. The basic Cos graph looks like this. Not so? There's a B in front of Cos, which means to say there might be an amplitude change. So how do I calculate B? It's going to be again your maximum, which is 2 minus your minimum. What's your minimum value on your Cos graph? Yes, well done to all of you. -2. You're saying it all at once. I can't make out. So you're going to get 4 over 2, which is 2. Your B value is 2. Right. People, is there a vertical shift on this graph? No, because it's 2 and -2. Okay? We need to know our basic Cos and sine graph. So your Q value is 0. So there I got my A, my P, my B, and my Q. So what I'm going to do is, I'm going to write the change on the here next to the graph, so that we can move the graph 1 unit up. And we can move the graph up a bit, okay? So we can get the questions in focus. So it's going to be 1, so it's a sine x minus 1, whilst f of x is equal to b, which is 2 cos x. Okay? So there we go. Sorry. Hello. Sorry about that. So let's look at the questions that follows. So the first question says, okay, we've done the first question. The second question says, the second question says in 4.2, write down the range of f. So what type of graph is the f of x graph? It's the Cos graph. So it starts at 2 and goes all the way to -2 and back to 0. So what's the range of this graph? It is between -2 till 2, not so? So what do I say? Y is greater than or equal to -2, but less than or equal to 2. Okay, you all okay with that? Okay. Silence is means to say you approve of it. G of x. They ask you for the period of g of x. What type of graph is G? The sine graph. What is the period on the sine graph? Normally, yes? 360. Is there a period change? Is there a value in front of x there? No. So, the period of this graph is 360 degrees. The number of solution or solutions to f of x equals g of x in the interval x is greater than or equal to 0 but less than or equal to 270. What does this mean? It means to say that this question must be answered only between what is given there, which is the given interval. Answer? What does solutions mean for f of x equal to g of x? What do we actually calculate when we say the two graphs equal to each other? What do we work out, people? We work out the points of intersection, yes. And at how many points does these graphs intersect each other? Twice, yes. How many solutions are there? 2. So the answer there is 2. They didn't ask us to work it out. They just asked us for the number of solutions there are to the graph. You guys understand? Okay. And in 4.3 the question says, the graph of h of x, okay, so here's a new graph coming into play, is obtained by reflecting g of x. So g of x graph is g of x equal to sine x minus 1. And reflecting g of x above the x-axis. So what happens if something is reflected in the x-axis? In x-axis, the y becomes negative. Not so. So if it's reflected in the x-axis, y becomes negative. G of x is a y. So negative y is equal to sine x minus 1, which now becomes y is equal to negative sine x plus 1. Okay? About the x-axis. Translating it 1 unit down. 1 unit down. So, if it moves 1 unit down, then what do? I subtract 1 on the x. Not so. So, translating it 1 unit down, so minus 1, so that cancel. So, I'm now left with negative sine x. And that is a graph of h of x. Okay? Move 1 unit down. The coordinates of the minimum point. So you're looking at the minimum point on h in the interval from 0 to 270 is. So what I do is, if I must draw this graph. So the negative sign graph will do that. From 1 to minus 1. And what's the question again? Right, the coordinates of the minimum. And you all agree there's the minimum value. Not so? So the minimum value here is going to be at 90 and at negative 1. That's the answer that you're looking for. Okay, do you all agree with that? Is that correct? Otherwise, you could have used the graph itself. Okay? If I take the graph itself and I take the transformation into account, the graph is obtained by reflecting g above the x-axis. So if I reflect this in the x-axis, the g graph, so that point goes there. This remains there. This is 270 and negative 2 become 270 and 2. So there's that graph. Okay? Then it moves 1 unit down. So if it moves 1 unit down, it goes there, that goes to 1. So there's that graph of h of x. So they ask you what's the minimum value? Of course, the minimum coordinate is at 90 and negative 1, which also makes that graph. Okay? So two ways you could have done it. Both ways will get you your 2 marks now. Okay. Let's look at the next question. Right, so in question 5, in 5.1, the question says solve for x. If 2 sine x minus 1 is equal to 0, where x is an element of negative 360 to 360. So here we got the restricted domain. So once we go into the general solution, we must determine the values for which x falls in that interval. Okay? So there's one of 2 ways. You can determine the general solution and then take it from there, and that's the method I'm going to apply. Or you could have gone straight into eliminating the values, or getting the values, calculating the values between those 2. Okay? The reason why I always apply the general solution method, because it also gives us practice on general solution. There's no marks allocated for it. Okay? So the first thing we do is we take it 1 over. The idea is to isolate sine x. So we then have 2 sine x equals 0,5 minus 1 plus 1 becomes 1,5. So 2 sine x is equal to 1,5. So what do I do now? Divide by 2. So I divide by 2, I then get sine x is equal to that 0,75, I think, which is 3 over 4. Not so? Is that correct? So what do I do now? I apply my reference angle. So I go arc sine of 3 over 4. So we need to pull the calculator up now. So we got arc sine, shift sine of 3 over 4. It's going to give you 48,59. Do they specify how many decimal places? No, so we go with 2 decimal places. Unless they specified otherwise, okay? So I would have marked you right on 1 or 2 decimal places here. Okay? But I think the instruction, initial instruction says 2 decimal places. So it should be more proper to write it in 2 decimal places, unless otherwise stated. Okay. So which question come to mind at this point? In which quadrant is sine positive? Not so. And which quadrant is sine positive? Quadrant 1 and 2. Not so. So let's go with quadrant 1. It's simply going to be the angle, which is x is equal to 48,59 plus k times 360. Not so. Or, on the other hand, in quadrant 2, it's going to be x is equal to 180 minus 48,59. Remember, to get into the second quadrant is 180 minus the angle, the reference angle, okay? So put there 180 minus the reference angle, which you just calculated, is 131,41. 131,41 degrees plus k times 360. And why k times 360? Because of the period on the sine and cos graph is k times 360. That's right, k times 360. And we mustn't forget to say that k is an element of integers. But remember, there's a restricted domain. So if the question was for general solution, that's where I stop. Okay? But that wasn't the question. The question was the restricted domain. So I now say, therefore, x is an element of, and you start listing. You start listing by saying k is 0. We put 0 through here, I get 48,57. 59, sorry. If I put 1 through here, it's going to be 48,59 plus 1 times 360 gives us an answer of 408,59. Which means to say that is outside this given domain. Not so? Do I have to write it down? No. So what I then do is I replace that positive 1 with negative 1. And I get negative 311,41. Is that inside the given domain? Yes. So I write that down. So it's negative 331,41. If I put negative 2 in here, what do you notice? It's going to be outside. It's lower than negative 360. So I don't write that down. And I of course do the same on the other side. for that quadrant, so it's 131,41 if k is 0. And if k is negative 1, of course 1 is going to take you outside. So it's 131,41 plus negative 1 times 360. Or I could just subtract the 360 from it. It's going to give you an answer of negative 228,59 degrees. Okay. And there's your 4 solutions in that given domain. If I'm going to go with minus 2, it again will be outside the given domain. Make sense, people? Okay. Then in the next question, in question 5.2 we are given, I have to cut that separately, but anyway, the question says 5.1.2, 2.1 sorry, simplify the expression. So as you can see, there's a negative angle involved there, add 360, so it becomes sine negative 210 plus 360 is 150, is that correct? Right, so 150 degrees is in which quadrant? In the second quadrant, which is 180 minus 30. If you wanted to work with a negative angle, there's no problem with it. That would have simply been negative 180 minus 30. Okay, we still take it to the second quadrant. Okay, but we have a positive outlook on life, so we work with the positive angles. Okay. So 300 is in the fourth quadrant, so it's going to become cos 360 minus 60 plus. Now 90 plus x is the same as x plus 90. You all agree with that? So 90 plus x is in which quadrant? Second quadrant. Is cos positive or negative in the second quadrant? It's negative. Although it changes to the sign, it's negative in the second quadrant. And cos changes to sine, so it's going to be sine x over 360 plus. Which quadrant is that in? Quadrant 1. Sine positive or negative? Positive. So it's going to be sine x. Okay. So 180 minus, you take it to the second quadrant, sine is positive, so it's sine of 30 over 360 minus, fourth quadrant, cos is positive, cos of 60. The sines of course cancels, leaves you with negative 1. Okay. So if you knew that cos of 60 is the same as sine of 30, then you could have cancelled this out, give you 1 minus 1, which is 0. Not so. But we are going to act stupid and we say, okay, we don't know. No? So that we can draw the special triangles. Okay, so you guys are more special in your own way. Not so? Yes. Okay. So let's go. Sine of 30. What is sine of 30? 1 over 2. Divided by cos of 60. I must use this angle here. Not so? Cos is adjacent over hypotenuse. So it's 1 over 2 minus 1. So half divided by half is 1. And 1 minus 1 is 0. Okay. Fairly simple, no? If somebody else do it. Alright? Then in the next question, we are asked in 5.2.2 for which value or values of x will a, where do we get a, which is this expression, be undefined for x is greater than or equal to negative 360 but less than and equal to 360. So when will this be undefined? This will never be undefined because that is a definite, it's a constant. Not so that it will always be half. Okay? However, this here will be undefined. We sine 360 plus x is equal to 0. That's the only time will be undefined. Okay? So 360 plus x is in which quadrant? Quadrant 1. Sine is positive in that quadrant. So that simplifies it to sine of x, where sine of x is equal to 0. If it's 1, minus 1 or 0, I take it to the sine graph. So I draw the sine graph. Okay? So there is a sine graph. So that is 1 and minus 1. So where sine of x equal to 0? Remember that's 360. Is that 0? 180 and 360. Not so. Restricted domain. So if I had to write this as a general solution, this would have simply have been x is equal to 0 plus k times. This is happening every how many degrees? 180 degrees. Or you could have said, if you don't want to write it like that, you could have said x is equal to 0 plus k times 360, or x equal to 180 plus k times 360. It's the same as saying this here. You all agree with that? But the restricted domain is from negative 360 to 360. So in other words, x is an element of, I could have just said 0, 180, 360, and on the other side, negative 180 and negative 360. Now say we didn't know that. We go with k is 0, so it will be 0. K is 1 is 180. K is 2 is 360 plus 0, which is 360. K is 3 is going to give you 540. It's outside. Okay, now we go minus 1. It's negative 180 minus 2, negative 360. And that is your solution. Otherwise, you could have written it x is an element of 0 plus minus 180 plus minus 360 is the same as we have there. Okay? You will agree with that? Okay, so let's take this off. The next question, our favorite general solution. Everybody's supposed to have picked up 6 marks here. No? So proud when I saw your papers. Everybody did. No? Let's say so for the video for now. Okay? Others will think we like, at another level. This question says determine the general solution. Okay, remember, we can never divide by a variable. Okay? You have x squared plus x is equal to 0. If this was the question, x squared plus x equal to 0. How do we solve for x here? Common factor. Do I ever divide by x here? Huh? So x equal to 0 or x equal to negative 1. I never divide by x. So why do you want to divide by cos here? Okay, so we'll continue from this point tomorrow. Okay. People enjoy the rest of the day. Good morning, class.